So here we're just given a simple capacitor, and we're given some boundary conditions for this capacitor. We have the current at time equals 0. Then we have an expression for the voltage here. And this is up to and at time 0. And then this is the expression after 0. And so they're asking us to calculate the two exponential term coefficients. So that would be this A1 and this A2. And so here it's just a matter of applying the boundary conditions to do that. So let's see how we would go about that. So the first thing we notice is that we can determine that we have VC at 0, and we know we were given that. That's this equation here is equal to 5. But also at 0, you see it has the line under equal, so these two must be equal. So then we can say this has got to be equal to A1 T E minus 100 T plus A2 E minus 50 T. And then that's at T equals 0. So at T equals 0, that's going to be 0, which makes this whole thing equal to 0. So then what we're left with then is A2, and at 0 here, that's going to be E to the 0 is equal to 5. Well, E to the 0 is just 1. So therefore, we know that A2 has got to equal to 5. So there's 1. Okay, so we also know by definition then that the current across a capacitor is equal to the capacitance times the time derivative, the time derivative of the voltage across the capacitor, or the derivative with respect to t. So in this case, we'll be taking the derivative of this guy here. And when we do that, we see that we will have 100 times 10 to the minus 6. So that's my capacitance, that first term. So that comes from there. And then that's going to be times, and then there's just the derivative of this guy with respect to t, which is, we should be able to do observation. So it's going to be A1 e to the minus 100t minus A1 times 100 t e to the minus 100t. This is just the chain rule. And then minus A2 times 50 e to the minus 50t. Okay, but we already know A2 is equal to 5. So then we can rewrite and rearrange some things here. And we know that IC of 0 at 0 is this point right here. And so they gave us that as 5 times 10 to the minus 3. So that's going to be equal to this guy as we combine terms. And so what we get then is 10 to the minus 4 times A1, and then E, and this term is going to be 0 because t is equal to 0, so e to the 0 minus 5 times 50 times, again, e to the 0. So you can see when we let t equal to 0, that made this one go to 0, it made this go to 1, and it makes this go to 1. So when we solve all that, what we come up with then is that A1 should be equal to 750. So therefore, there's our two coefficients that they asked us to solve for. So we can take those and plug those back into here to have a general expression for the voltage across the capacitor.